Okay, so 9.1 was just learning about inequalities greater than, less than, how you kind of express it in real world situations. 9.2 is solving them now. This is going to be just like the stuff we finished doing in chapter 8. It's all single step. Hopefully everything's going to be pretty straightforward. There's one thing different in regards to dividing or multiplying by a negative number, but otherwise it's all the same as chapter 8. So the only thing that's different, if you divide or multiply by a negative number, you have to switch the inequality sign. We'll go through some examples so you see it, but if it's starting out as a greater than sign, you multiply by a -2, it becomes the opposite. So, looking at the first example, you still want to solve for x, just like we did through chapter 8. So you need to figure out how you can get x by itself. In this case, you need to divide by -4 because this is -4 times x, so divide the left side by -4 and divide the right side by -4. So the 4's will cancel. 12 divided by -4 is -3. Now we divided by a negative number, so the inequality will switch. So it started out as less than, and your final answer it is greater than. So this is your final answer. Now to check that, you'll have to verify this. So x can be any number that is greater than -3. So -2, 0, 14, all of those are bigger than -3. So if you go into this verify section and take -4 and multiply by a number bigger than -3, which -2 would be bigger than -3, that needs to be less than 12. Notice that we went back to the original expression. So -4 times -2 is -8, which is less than 12. So this works. Second one now. Again, it's just single step equations. X minus 4 is greater than or equal to 1. So to get, again, you want x by itself. So you will add 4 to the left to cancel those 4's out as it'll equal 0. Then add 4 on the right and you will get 5. Now this time, adding, subtracting, positive, negatives, doesn't matter. The inequality sign stays the same. So this will be x is greater than or equal to 5. And now to verify it, you can use any number, including 5, or larger. So if you used 5 itself, 5 minus 4 needs to be greater than or equal to 1. 5 minus 4 equals 1, which is greater than or equal to 1. Or you could use, say, 18 minus 4 needs to be greater than or equal to 1. 18 minus 4 is 14. So that also fits. So the inequality expression we got here is correct because we verified it and it works both times. Okay, last part, and then you can do some work out of the book. We still want x by itself. Okay, on the left side is -6 is greater than -x divided by 5. So you still want x by itself. 5 is being divided by here. To cancel it out, you will multiply the right side by -5, which cancels it out on the right, and then on the left, multiply by -5 and you get 30. And the last step is to look at the inequality sign. You multiplied by a negative number, so the inequality becomes less than. So make sure you can see the difference here. Okay, start out as greater than, multiply it by a negative number, Now it's less than x. Okay, so 30 has to be less than x. So when we go to verify it, whoops, let's use black again. So -6 has to be greater than whatever expression you end up with on the right. So if 30 has to be less than x, if you choose, say, 40, okay, that'll work because 30 is less than 40. So 40 divided by 5, make sure you include the negative that's still there. So -6 is greater than -8. So again, this is proven true, so your final inequality expression of 30 being less than x is correct. Now you can work through these questions. If you're struggling and can't quite figure out, there's always, B, C, D to do as well. Okay, but I think just doing a couple of each should be enough for you to understand what's going on. Okay, the last part, as always, is problem solving. So Frank went to a sale at Toys R Us where all the PlayStation games were on sale for $19.50. His mom told him that he can, at most, buy only $435.75 worth of games. Yes, Frank and his mom have lots of money. So you need to write and solve an inequality that will determine the amount of games that he is allowed to buy. Okay, and let G be equal to the number of games he can buy. So again, you're setting these up kind of similar to what we did in Chapter 8. So the total amount of money he can spend is $435.75. Okay, you know that we're going to represent the unknown number of games with G, and each game is worth $19.50. So here's your expression. The last part now is what inequality goes in between the two. So looking at this, he can't spend any more than $435. It has to be less than that. So 1950 times G must be less than or equal to the total amount of money he's allowed to spend. So, solving this equation now, you need to have G by itself. So to do that, divide each side by $19.50. So it cancels on the left. Divide 435.75 by 1950, and you end up with an answer of 22.3. So the total number of games he can buy is, in the end, 22. You can't buy 0.3 of a game, so you just round to the whole number that makes sense. If this was 22.7, he can still only buy 22 games. You can't round up and say you can buy 23 games. He can only buy the amount of money he has. So the last part is just a few problem-solving questions. Work through it. Ask questions if you're unsure. And one more section for Chapter 9.